Hi. So I don't know how many talks have been a little bit detail on the IoT side of the conference. So most of them might have been blockchain. So this is a little bit technical IoT side. So yes. So this is me. This is my lab, private lab. So I've been working for many years in many different fields and corporate startups and private researchers. So you can look at my GitHub or website. I have a lot of art projects you might find. And let's dive into the topic. So, yeah. So today we are going to talk about, as I mentioned, it's more about technical details of IoT and over-the-air update, OTA part of IoT and why we need that. So this is the agenda. You need to click twice, yeah? Yeah, it's fine. So I just want to ask how many of you are on the hardware side and how many of you know a little bit on the hardware side, functional or like embedded system side. Okay, so this is like very often people, even in the universities, they differentiate embedded system from functional specific to general purpose. So functional specific is a small device which is low powered. Yeah, is it okay? Yeah, which is usually a microcontroller with a limited function, running for many years. Is it loud enough? Yeah. And general purpose embedded systems are usually the gateways, and you can see like Raspberry Pi or your smartphone is a general purpose embedded system. So today we're going to talk about IoT for both the sides and also the OTA for both devices, both type of embedded systems. So some of this slide missed, I don't know why. So anyway, there is a rise of embedded systems, and embedded systems are IoT devices or mobile phones or your new set-top box or any kind of these kind of devices with the functionality, doing some tasks, which is basically a small computer. You can see, I mean, I don't know whether this number is real. I just got it from internet. So there are going to be more and more embedded devices, IoT devices. And this slide was supposed to show that what could be those devices. So at NBT, we have also one venture which is making a smart diaper. So IoT devices can be anything and which are connected. So the problem of most of the devices, they are not updatable, or they are kind of brick devices which has no access to the outside world. So this was a recent news, Bluebone, which was security vulnerability in Bluetooth chipsets. So many of them were not updatable, and that kind of put all these Bluetooth devices in a vulnerability. So it's the same with another type of a board, bricker board, which actually makes all these devices bricked in a way that you cannot access them from the outside world. So even people think, okay, there is no bugs, there is no vulnerability in Linux, but usually even Linux kernel has a lot of issues. You can see that the red and the orange one, they are like critical issues and high vulnerable issues which stay in the kernel for a long time, and people think that, okay, you get an embedded system, you don't have to update the kernel or like, you know, the bootloader or whatever, which is in the system space. And a lot of the update happens on the application, but the security issues are underlying. So, why do we need an update? So the talk here is mostly about like we need update for the security patches. Some companies here, you can say they deliver half-finished product and deliver a lot of features over the OTA. And bug fixes, migration. Sometimes you have a user data which has to be migrated from one system to another. Emergencies are really a new use case. You can see that what happened with the Tesla cars. When there was this storm last year, they released an update that actually unlocked all these cars with 150 kilometers more range in their batteries. So downgrade, sometimes you release something on the Friday and you come back on Monday, you see that, oh, okay, you have to downgrade now. So, so never release on Friday, please. And So where we need an update, mostly like people don't update bootloader. It's the fire part, the dangerous part. And kernel is rarely updated, and root file system people update very less, and most updated is the app. So here I've been, here I have a firmware application SoC is kind of a functional specific system, and usually like a lot of chipsets that you use in a general purpose embedded system, something like if you want to have a, let me say, Bluetooth on your device, and then you have to buy a chipset that has its own firmware protocol stack that has to be updated. For a lot of companies, the problem of Bluebone is that a lot of these devices with the Bluetooth chipset was not updatable, because people thought that, yeah, it's not necessary to update. We really had recently, I can show you one of the product from NBT that we were using a wireless M-Bus module from one of the big manufacturer. We said, okay, we're going to put your module, and we need you to tell like how we can update. And they said, oh, you don't have to update because we have tested the firmware, there's no security fault. And then people believe that it is like that. But always, if you have a connected chipset, it has a firmware that has to be updated as well. And kernel and the device free, if there's changes in the device and GPIOs, and which goes into device free, and kernel has to be updated for the mainlining the kernel. And system space, whatever, if it's a busy box or any other login manager or any other root file system, that has to be updated as well. User space applications are your applications, and you have also the credentials like API and API keys and stuff. The one thing that manufacturer configs, like specific to things on your hardware, people, for example, one of the product that I made previously for one project that has a gesture sensor. So there was a calibration data that was saved, and we found out that we found a better calibration data than what we have released. So we didn't have a way to update them, and so this is one of the important things that you might have to update the manufacturer data as well. Is it? Okay. So just a simple example. This is one of the product. It's a functional specific system, IoT device based on NRF. You can see this is master boot record that you cannot change it. It's with the SoC, and usually the protocol stack is here. NRF calls is soft device, and most of the time people don't update that also. And then your application space, and this device firmware update bootloader is something which creates a Bluetooth connection so that you can send your firmware. And this is these user manufacturer specific data and also the user specific data. So usually it's very limited, and you don't have much space, so you update mostly this part of the product. And we have, this is one of our product that we delivered recently to Take Evo. It's a multifunctional gateway, but used for submetering. This is the hardware you can see, and we have many modules here. They have their own stack. And we have to find a way that it is updatable by the processor. So you have to keep those lines, whether it's UART or SPI, so that it can release an update to these modules whenever we need. And basically, this is the operating system stack of that built using Yocto. So usually where the software is stored are different places, and they have a different file systems. For example, if you have to have a file for NAND flash, is the UBI, and then if you have ext4 and this, and depending on the storage, you have a different package that has to be released. So the interfaces, usually in system programming, SPI UART, or people use to update things, just manually going there, replace things. And with any RF interface, you can find a transport to send your firmware or the software. And nowadays, this is also available for IoT devices. And if you have a TFTP server or cloud update, you can do that as well. So I just want to directly go detail into what are the patterns available. So one is a single copy update. Just completely replace the binary region with the new firmware. That's very common in microcontrollers, and there are many frameworks that does manufacture specific. This is if something fails, your IoT device is basically bricked. So there are fail-safe mechanisms provided by these people, but it's not that much fail-safe, or there are chances that can be bricked. So this is overlay or delta, which is basically like a Git. It takes the differences and it just updates only that part. And smaller package size and faster time. And the problem here, it has to do a lot of operation on the root file system. For example, if you are making a product for industry that has to stay for 10 years, this is going to kill your memory, right, whatever the flash it is. So there are many tools which are using, even Tesla is using this Harman Smart Delta technology, which is basically Samsung-owned technology, and Snappy, OS3, open source ATS Garage, which is made in Berlin. The best one is this dual partition update. So the thing is that every time that you update the whole image, and if everything goes well, it's an atomic update. You just flip in the bootloader, okay, go to the new boot partition. So in this way, you can make sure that the whole image, even your dependencies, your root file system, everything is updated. The problem is that, yeah, it's a big package usually, and even though the compiled size of a kernel is around 5 MB, but you will have a bigger root file system, which might usually, like embedded system, have around 300 MBs of image, which has a very strong rollback and 100% unbreakable mechanism and less read and write to operation. It's just write to do that and replace, change the bootloader option. And the one which is automotive grade and a lot of people started using, and Mender is one of the best in this category, and Rauk is also there, and which is where you need to have a lot of work for the deployment server and stuff. And the modern one in the markets, yeah. So just have a look at my T-shirt, yeah. So containers are Linux, but please choose wisely, yeah. So people think that, yeah, if you have a virtualization, then your system is protected, but choose the right container, because if you have a problem in the container, your system is exposed. And there are many of them now, but Restin is well known for embedded system. You just pull in a new image, very easy for a development, and usually the system space is not updated, but like these guys are providing a way to update that as well. So usually these type of containers. And yeah, basically the problem or all other parameters or facts people look into to OTA solution when they want to evaluate something. Usually, like, most of them, all of them provide sign and verify update packages. Yeah, it's secure and verified boot from bootloader, so that your images are verified in every stage, and usually error correction, sanity test, checksum. Atomic update provides this kind of a thing that you get the whole image, so that you're not you don't have incompatibilities between your updates. Usually that happens like you have a release 1.0 and then you are now in 6.0, and you always see that what's the 5.9, and you target your, you don't see that if there is a device with 1.0, you kind of break things, and this compatibilities issues can happen. And watchdog, hardware watchdog is enabled, so that if it's stuck in any place, you can reboot, rollback mechanism. So mostly all the platform provide these kind of features, but you have to choose the one that is more suitable for your embedded system, how much space you have, how much of network traffic you can allow, and all those things. So just coming to the tools itself, Mender, yeah, very well done tool. Nowadays you can see them everywhere in all the embedded Linux conferences. Atomic update mechanism, they provide a complete server and UI that you can manage the device management and artifact management, deployment, and everything, completely open source, and provides Yocto and U-Boot integration. And you can also get it enterprise solution from them. ATS, made in Berlin, our friends, very good, and now recently acquired by here. and they do for automotive and very light update, and they have also build root integration, open source, and very light update packages uses the Delta update mechanism using another open source tool called OS3. And Resin, yeah, it's containerized and made in Docker and Node.js, providing similar thing for when your application, you're very much application heavy, and then you should look for Resin. And Rauk, the most flexible one, which provide all type of update mechanism and supports all type of bootloader, and the best one I would say. If then the problem is then you have to develop your infrastructure. How do you manage the devices, and how do you know which devices you want to update, because this is kind of a command line one-to-one tool. Another thing is that most of the time you don't have to update the system. It's just a small software, usually a small few KBs of software that you have to update. And there are many tools which is like apt or aptitude or yum, or which is used. These things are very well used in embedded system, OPKG and Smart and pip. So pip is for Python projects, and you can define in your Yocto build what packages you want to build, and based on that you can use the system. It's very simple to update. You just need a web server, put these packages, and connect this to how you with the Debian apt. And okay, I just want to show what we are using, what I have used in my past projects. So this is the latest one that was delivered to Degevo Submetering Gateway, which uses Mender and OPKG for the package management. Underlying is Mender. And then this was my previous company where we had a Scenic hub based on Allwin H3. We use Mender and pip because the whole application space is Python, home assistant based home automation thing. So you can have a private pip repository, make your Python X, deploy it there, or you can even have the packages there, and then you can do a pip install on the hardware side in the target. And this is a IoT device, functional specific, which uses dual bank device firmware update, DFU, which is Nordic Semiconductors tool, which works very well. And this was one gateway that I worked before. Yeah, people try to do this mistake. They try to make a tunnel and send the code to the gateways, and this is really a dangerous part because anyone can send anything. So basically they send shell script, but then later they move to OPKG, but I don't know whether they are still updating the system space. This company is based in Berlin, and 5 years ago I worked in this project based on Chrome OS. Chrome OS has its own updating mechanism using SW update, and again its own packages, and then it's done through that like how you do with apt-get update. So basically this is everything about over-the-air update. It doesn't mean only that it has to be over the air, it can be through the cloud or like any other interface. So when you are building an embedded system, and if you have a module to place on your hardware, if the module doesn't provide any other way, the manufacturer, if they don't provide any other way to update their hardware, please don't use that module at all. It's very simple. You will always find the best other modules which are updatable so that your product can be updated anytime in future. That's it. So